So it's finally here, the PCB for the automated plant watering system that we designed in one of my previous videos. Today I'm going to be doing a bit of an unboxing from JLC PCB. So this is the PCB. As you can see, we've got the logo for engineering experience, we've got a ESP32, our USB-C controller, all the little buttons and everything, and the slide switch for the power control. Obviously this was, I think, a 4-layer board with 2 regulators. We've got a buck boost converter for the 3v3, and we've got a 5-volt boost converter for the sensors and the pumps and everything like that. As you can see, the board looks great. However, the board doesn't work. So let me kind of walk through some of the design decisions that I've made, what I think could be wrong, and maybe why the board isn't working. And I love your input on this, so please let me know what you think might be wrong. Obviously, I tried to use the ESP32 onboard USB functionality that's given. However, it's not working as I thought it would. So if you have any ideas, or if you've designed a similar board in the past, please let me know. But before we do that, here's a word from our sponsor, JLC PCB. JLC PCB is one of the leading PCB manufacturers in the world, with cutting-edge machinery and factory, known for their high-quality printed circuit boards and exceptional service. I've used JLC PCB many times in the past for my personal work and for professional work, and the quality has always been exceptional. So whether you're a hobbyist, a student, or a professional engineer, JLC PCB has everything you need to bring your electronic projects to life. They offer a wide range of PCB options from single layer to multi-layer boards, all at incredibly affordable prices. They offer quick turnaround times so you can get your assembled boards in just a few days. Plus, they always seem to have a discount on your first order. And the quality is top notch. Each board goes through rigorous testing to ensure you get the best possible product. They also offer various customization options like different solder mask colors, surface finishes, and more. So if you're looking for a reliable, affordable PCB manufacturer, head over to jlcpcb.com. So let's get back to the video now. And one of the first things that I wanted to talk about was the power on-off control that we went through in the last video. Basically, we have a power switch over here, which is a toggle or slide switch, and we also have a push button. So if you remember back to the previous video, this switch was going to be used for development only. The switch works, and the power to the 3v3 basically comes on properly. However, I should not have connected pins 3 and 4 to ground. I should have left them floating. What happens right now is when I toggle the switch to the bottom position, it basically grounds this input over here so that the 3v3 doesn't come on with the push button. If that was floating, then the push button and the toggle switch can work at the same time. However, this is a development board, so that's fine. For the final thing, I would basically just remove the switch anyway. One of the other things I noticed is that I'm getting slightly higher than 3v3 volts on this line over here. Now that's okay for the regulator that we're using, which is basically this buck boost converter over here, the TPS63070. So that's not an issue, but I was targeting 3.7 volts. So maybe one of the things we can do is increase the resistance down here. But if you remember back to the previous video, we wanted to keep the component count to a minimum. So that's what I've tried to do basically. So you can see I'm reusing some of the components so that we don't have too many bomb lines. Now coming to the main problem, you can see I've got a USB-C connector running USB 2.0. So basically I'm using a USB-C connector that you can see over here. I've got USB-DN and USB-DP, which is basically these 2 inputs from the connector, and they go straight to the ESP32-C6 microcontroller. And the pins for it, I'm using basically pin 17 and pin 18. Now this pin should allow us to basically program the ESP32-C6 with our USB-C controller without needing a UART bridge or other such components that you typically see on a ESP32 dev board. However, this is not working for me. I'm not sure why. So some of the things that I've tried, basically I've tried to have a pull-up resistor on the D plus line. So I've got basically put a 1K5 pull-up resistor from here to 3v3. That doesn't seem to make a difference. When I first power the board on or plug in the power supply line, basically the USB-C connector, I'm holding down the boot button and releasing it. That doesn't seem to make a difference. So not a lot is different from a typical dev board in terms of the USB-C connector, and basically they also don't have a pull-up resistor on the dev board. So I'm not sure entirely if that's the reason why it's not working. although I think there was some documentation in the ESP32 datasheets somewhere where it says you do need a pull-up resistor on DP. However, that did not fix my issue. Typically they'll have a UART bridge which goes to this, so I think, safest bet would be to just go for that. Obviously I wanted to reduce the components on this board, so I didn't use it, but I think in hindsight I probably should have. One of the other things I've noticed from the datasheet or kind of the programming guide for ESP32 is that GPIO8 plays a part in the boot up sequence for one of the boot up modes. I'm not entirely sure that that's the issue, but I think I should have left GPIO8 open with a test point or something like that so that I can probe it if I need to. So just to give you a bit of a recap, the microcontroller that I'm using is the ESP32-C6 Mini, and it's basically the one that has the integrated antenna, as you saw on the kind of the unboxing for the JLC PCB video at the beginning. On this datasheet, you can basically see where the boot options are. And basically if you go to strapping pins over here, you have several different boot modes. So you've got chip boot mode, which I think is the one I'm using, but I'm not entirely sure. So it does say GPIO8 over here, which I'm using for something else. And you've got JTAG source control, GPIO15, but I don't think I need to use that, to be honest. Now there was a configuration for what we need to do in terms of this, and it's somewhere around here. So you can see download boot, which is basically the function I think I need, where I need to put GPIO8 to a value of 1 and GPIO9 to a value of 0. Now, if you look back to this circuit, I'm using GPIO8 for enable 3v3. So I'm doing that anyway. So that is going to 3v3. And on startup, when I plug in power for the board, I'm basically pressing the switch. So putting GPIO9 to 0. So I should be getting this boot sequence or boot mode control, but that doesn't seem to be happening. So when I plug it in, I just get an error from Windows basically saying that the device is not recognized, and that there's some error with the kind of the descriptors of the USB. I have tried different cables as well, so not entirely sure what's wrong. If you know what's wrong with this circuit, if there is something wrong with the circuit, then please let me know. That'll be very helpful, and then maybe I can get the circuit and the PCB modified. I'm still trying to make it work in a slightly different way. I might get a UART bridge or something like that externally to see if I can actually plug into this somehow. If that's not possible, then obviously this project's going to be a bit more difficult, but I've still got my kind of moisture sensors and my pumps and everything, which I can use with a separate board anyway. I would lose the IoT functionality that I wanted. One of the things I wanted to talk about was the TPS63070, which is working great with this power on circuit over here. And this charging circuit, all of that works fantastic. When I toggle the switch to down, the 3v3 comes on and basically powers the microcontroller fine. And when I remove the toggle switch completely and just press the switch button, the microcontroller also comes on. Obviously, I can't basically write code to this at the moment, so I can't hold the 3v3. So that's a bit of an issue, but yeah. The boost converter I basically can't use at the moment, so I can't confirm if that's working or not working. Obviously the pressure sensor I can't use at the moment because that's all dependent on the microcontroller being able to program. So there's a few things that I can't confirm if they work or not. All of this seems to work. The charging circuit works, the 3v3 buck boost converter works. So yeah, that's all good. In one of my future videos I will go through how to use the moisture sensor, how to use a water pump and things like that. Hopefully by that time I'll have fixed the issues with my board. Just for your information, I can quickly go through the PCB design as well. I think focusing on the USB-C side of it. You can see I've forgot to, I think that's where my issue is. Damn. So you can see I've basically, for some reason this has been deleted. So I should have a connection going from here to this, and I should have a connection going from here to this. Luckily, this is an issue that I can fix. Hopefully, if the pins are not too small in the microcontroller, which I can see, they are quite small, but I should be able to fix this. So I'm going to try that and see if I can fix it for my next video. So I'm basically, what's happening, you can see, is that I'm losing half of my data line on basically this not being connected. And I did go through all my DRCs as well, so I'm not sure when this pin was removed, but that's a big shame. I think that's the major issue with this. And you can see the DRC is still not flagging an issue with it. I don't believe it's an issue with KiCad, but the DRC check is not flagging this as an issue, or not flagging A7 not being connected as an issue, which is a shame. Yeah, I wonder why that is. So what I'm going to do now is just show you me trying to fix this issue. It's going to be quite difficult, but it should be worth it, so we can see if the board works in this video. Progress of a kind. We've got the USB JTAG serial debug controller basically appearing on the device manager, but you can see that it continuously disconnects as well, which I'm not sure if is a soldering issue or maybe a pull-up resistor is also needed, which I've tried in the past. So I can try a pull-up resistor on the D+ line to see if that helps. But if that was the case, then I don't think it would be detected. So that's all I have to share with you for today. I don't have a pull-up resistor to test at the moment, so I will need to get one. As soon as I've done that, I'll basically make an update video to see if the board works. Right now what I've done is basically just connect this section of the track to this pin over here. So obviously when you flip the USB-C connector, that it's not going to work, because DP is still not connected anyway. That shouldn't matter because I just need to get the right side of the USB-C connector connected to the USB-C connector on the PCB. I'll try some few things. I'm not sure why it keeps disconnecting. It might be a power issue on my USB port, so I can try different USB ports as well. I'll let you know how I get on. I might add an update in the description if it does work, but there will definitely be another video on this, so keep an eye out. Thank you for watching today, and don't forget to comment, subscribe, like for more, and hopefully we can get to the bottom of this issue. If you've had a similar issue in the past, let me know. Obviously this is a sort of a silly mistake to make, but I'm still not sure why the DRC check did not pick this up, so I'll need to investigate that, make sure that doesn't happen in the future. So thank you for watching today. Bye for now.